So in this latest video we'll be looking at volume of cubes and cuboids. Now there will be some notes and some worksheets in the description below for you to practice everything you've learned in this video. Now before we get started, let's just have a quick refresh on some key words. Now volume is basically, whenever you're asked to work out the volume of something, it's basically the number of cubes that fit inside a 3D shape. Now these cubes can vary in size, so it's really important that when calculating the volume you always state the size of the cube. So in other words, or you'd be looking at how many millimeter cubes are fitting inside a 3D shape, or how many centimeter cubes, or how many meter cubes would fit inside a particular shape. Now a prism is a solid figure whose bases or ends have the same size and shape and are parallel to one another and is consistent in area. Now this area is what we call the cross-sectional area throughout. Now here you can see prime examples of some quite common prisms that you may get. So a triangular prism. Now the cross-sectional area of a triangular prism is a triangle because that is the main face that's consistent throughout. You can also have a square-based prism where you've got a square and it's just elongated in terms of length. You can have a rectangular prism, which can sometimes look like a square prism. It all depends on what face you are sort of facing and to decide which two faces are parallel to each other. You can also have a pentagonal prism, a hexagonal prism, an octagonal prism, and you can also have a circular prism, which is also more commonly known as a cylinder. Now in terms of volumes of cubes and cuboids, now these are some key formulas that you need to learn. Now although I've mentioned that there are two formulas for each of these two shapes, so a cube and a cuboid, really depending if you're good at algebra and solving equations, then really you only need to look at using one of them. So let's have a look at what these two formulas are. So the important thing to recognize with a cube is that the main principle of a cube is that all sides are going to be the same. Now when working out the volume of a cube, it's basically multiplying all three of the dimensions where you've got the length, the height and the width. Now the nice thing about a cube is that all those lengths are going to be the same. So to work out the volume, all we need to do is multiply the three lengths, or as they're all the same, we can use the formula of L cubed. So depending on which you prefer, let's try and not write through the formula. So here I've got this formula, one of the two that I could actually use. Now in some more complicated questions, or reverse questions I like to call them, you may get asked to work out a missing side. Now if that's the case, then to work out the length of a cube when you're given the volume, is all we need to do there is do the reverse, which is to cube root the volume. And that will give us what the length of the cube actually is going to be. Now for a cuboid, that's going to be slightly different. Now with a cuboid, you can have at least one of those sides is going to be different. Now two of them may be the same, but more often than not, with a cuboid, all three lengths are going to be different. So the formula to work out the volume of a cuboid is going to be multiplying the three different dimensions together. So here we've got the height times the length times the width multiplied together. Now if you've got a missing side and you try and look at reverse question with a cuboid, then all we need to do here is divide the volume by the two sides that you do know. And again, we'll go through some examples of where we would use this particular scenario together. But if you're making any notes, then these are definitely four formulas that I would write down. However, the ones in red are going to be the ones that are most important. So let's have a look at some example questions. Now with more easier low-level questions, you can work out the volume simply by adding how many cubes you can actually see. Now when I say actually see, it's how many cubes there actually are in the shape. So what you want to do is imagine that you're picturing this 3D shape and then calculating how many there are going to be. Now the best way, most accurate way of working out the volume of a particular question like this is to work out what those three lengths are. So for example here, I've got 4 cubes going across. I've got 3 squares in terms of the depth or the width, and I've got height of 3. So here the volume is going to be equal to 4 times 3 times 3, which gives me 36, and it says that the cubes are centimeter, so it's going to be centimeter cubed, and there is my final answer. Now again, I could easily work this out by counting the cubes, but just recognize that if you are going to be counting the cubes, then how I would see this is see this as 3 layers of 12. So here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I've got 3 layers. So that's 1, 2, and 3. So if you do 12 times 3, it gives you the same answer of 36 centimeter cubed. So let's have a look at another question involving counting cubes. So here there are two views of the same shape made from centimeter cubes, and that's probably one of the most important things we need to look at. Now, what is the volume of this particular shape? Now, you can see here that we haven't got a complete cuboid because obviously some have been sort of taken out or just sort of dismantled. So what we can do is to kind of imagine, now you can do this by counting how many cubes you can see, remembering that there are going to be some that you can't see. Or you can, what I would recommend that you do is split this up into two cuboids. So what you can see from the green is I'm going to just simply split this shape up into two. So for this particular cuboid, I can see that I've got 3 by 2 by 2. So that's going to be 2 times 3 times 2, which is 12. And if I look at this particular cuboid, well, that's going to be 1 by 3 by 3. So here it's going to be 1 times 3 times 3, which is 9. And then to work out the total shape, all I need to do is add the two together. So I've got 12 plus 9 equals 21. And again, don't forget the units, which is centimeter cubed. Now, more often than not, you might get asked to work out questions where it's impossible for you to work out the count number of cubes that you can see. So here what they'll do is I'll give you the dimensions. So in this our first example here, we've got a cube. Now again, with a cube, you'll only be given one length. You may be given 3, you may be given 2. But again, the key thing to remember with a cube is that all the lengths are going to be the same. So to work out the volume of this particular cube, it's going to be 3 times 3 times 3. Or I could do 3 cubed on my calculator. And that gives me an answer of 27. Now looking at the units, which is centimeters, that's going to be centimeter cubed. Now for question 2, let's pick another colour. So again here I'm going to go for the volume equals 5.4 times 5.4 times 5.4, or on my calculator I could do 5.4 cubed. Now the fact that they're decimals just means that this question might be classed as a high level question, but the method is exactly the same. So whereas the first example could easily be done without a calculator, this second example is one where you're probably more likely going to be using a calculator. So if I do either 5.4 times 5.4 times 5.4 or use the cube button on my calculator, I get the answer of 157.464, and that's going to be in centimeter cubed. And again, I might get asked to round that up, so if I did, it would be 157.5 centimeter cubed, and that's to 1 decimal place. Now if a question asks you to round, then obviously you'll need to round. If it's got no mentioning of rounding, which this question hasn't, then you can pretty much choose your sort of degree of rounding. If you want to write down exactly what your calculator is telling you, then that's not a problem. If you want to round it up, go for it. But if you do round it up, make sure you always state what you are rounding it up to. And again, also don't forget the units. Now with question 3, this is a cuboid. So again, all I need to do here is multiply the 3 lengths that I've been given. So here it's going to be 4 times 8 times 5, which is going to be 32 times 5, which equals 160. It's going to be centimeter cubed, and there is my final answer. Now one thing I did forget to mention is that when you're working with either area or volume, when you're multiplying or combining two sides together, then it's really important that you first check to make sure that all the sides are the same units. So here is just a little statement is always check that all units are the same. Now this won't be a problem more sort of easy lower level questions, but for more high level questions, then this is something that you will need to kind of just double check and make sure. It kind of leads us into question 4. Now with question 4, I've got 7.5 meters as the height, 11.2 as the width, but I've got 660 centimeters as the width. Now with this, because I've got 2 out of the 3 lengths in meters, it makes more sense for me to convert the 660 centimeters into meters rather than the other 2 into centimeters, because obviously it requires more work. So what I'm going to do is I'm going to change 660 and I'm going to convert that into meters. So that's going to be 6.6 meters. So now working out the volume, it's going to be 7.5 multiplied by 11.2 times 6.6. Now one key thing is that there's no particular order that I need to multiply these 3 numbers together. Because I'm multiplying, the order doesn't make a difference. So if I did 6.6 times 7.5 times 11.2, I should get the same answer. So typing that all into my calculator, I get an answer of 554.4, and that's going to be meter cubed. So again, just don't forget, don't automatically think that all your units are all your answers, sorry, are all going to be centimeters cubed. So now let's have a look at what we call a reverse question. So in a reverse question, we're given the volume and we need to work out what the missing side is going to be. Now, earlier in the video, what I went through was I gave you a particular formula for you to use, which is not a problem. But again, it's an additional formula for you to remember. So ideally, if you just know the processes of working this out. So here, if I knew that volume equals length cubed, then substitute numbers in. I've got x cubed equals 729. So I want to work out what x is. So all I need to do is the opposite of cubing, which is cube root. So I do 729 cube rooted, and that gives me an answer of 9. So x equals 9, and it's going to be centimeters. Now don't forget that because we're working out length, there's no power that's needed in the units. It's just going to be single units. So therefore it's going to be 9 centimeters. Now, if I was to use the formula, then again, the missing side is going to be the cube root of the volume. Now, this formula only works for cubes, so it's going to be the cube root of 729. If I type that into my calculator, I get the same answer of 9. And again, don't forget the units, which is something I almost did. So moving on to question 2, again, what I'm going to do, so if I was to, let's say, use the formula that was given, so here the missing side is equal to the volume divided by the two sides that I know. So in this case, it's going to be x equals 510.72 divided by the two sides that I do know. Now again, need to make sure that this is in meters. So that's going to be 8.4 meters. So it's going to be 15.2 multiplied by 8.4. Now if you're going to type this in straight in your calculator, just make sure that the 8.4 is in the denominator, not lingering outside. And so if I type that into my calculator, 0.72 and 15.2 multiplied by 8.4, I get an answer of 4 meters. And there's my final answer. Now, if I was quite confident with looking at equations, well, I know that a volume of a cuboid is height times length times the width. So substituting numbers in, I get 510.72 equals and 15.2 times 8.4 times h. Now again, I could easily multiply these two numbers together, which gives me 15.2 times 8.4 gives me an answer of 127.68 multiplied by h equals 510.72. Now the opposite, I want to try and get h by itself, so the opposite of multiplying by 127.8 is 68 rather, is to divide by 127.68. So doing the opposite, and that gives me a final answer, or the exact same answer, of 4 equals h. And there is my final answer. And again, just don't forget to put the units, which is not centimeters, which seems to be a default. It is meters in this particular case. And there is my final answer. So now let's have a look at this third question. So here what we've got is we've got a square base prism. So here we notice that here we've got two sides, but one thing I do notice is that those two sides are the same. So this here represents a square. So looking at this particular question, now this one's slightly different to the one we did before, and the formula doesn't quite work. So with this, well, it does, but it just requires a bit of tweaking. So here I've got the volume equals the length times the width times the height. Now in this I know that the volume is 400, the length I'm just going to say is 16, and the width is x, and the height is x. So what have I got? Well, I've got 400 equals 16 times x squared. Now here I want to get x by itself, so the first thing I need to do is get rid of this 16. So the opposite of multiplying by 16 is to divide by 16. So if I do 400 divided by 16, it gives me an answer of 25. So x squared equals 25. Now I want to try and get x by itself, so I need to get rid of this square. How do I get rid of the square? By square root. And so square root of 25 gives me a final answer of 5 centimeters, and there is my final answer. Now if I was to use the formula, then here I've got the missing side equals, and it's going to be the volume over the two sides that I know. Now in this case, I don't know what one of the sides are, so here I've got x equals 400 divided by, and it's going to be 16 times x. Now this is where it gets a little bit more complicated. It's possible, so for example, I could take 16 times x over to the side. So here I'll have 16 times x equals 400. And then I've got 16x squared equals 400. And then again, all I need to do is take the 16 over, which gives me x squared equals 25 and x equals 5. And there is my final answer. And the answer is in centimeters. So entirely up to you which one you prefer, but again with this particular question, when you don't know two sides and they are the same, then I would definitely opt for the first method, as it just makes a lot more sense. It's less work for you to involve. So let's now have a look at an extension question. Now in this extension question it says boxes A and B are both cuboids. How many of box B could be packed into box A? Now again, this is a very common question that comes up. Now there's a couple of ways in which you can answer this particular question. Now, one of the most common ways of answering this question is to work out the volume of A, work out the volume of B, and then divide the two numbers and then round down. Now, that may be okay and may give you the correct answer. However, that might not always work for all types of questions, because the problem about using that particular method is that we may have like empty gaps. So for example, you may fill this much of the box, and by using that method here, we haven't got enough space to fit another row of boxes. However, what will happen is by doing that method is you're kind of melting that box B and filling that in the gaps, which is what we're not wanting. So what we have to do with this particular question is work it out sensibly. Now for this, we've got three lengths. We've got 10, we've got 15, and we've got 20. Now what you want to do is you want to see which of the three dimensions fits nicely with these three numbers. So looking at 50 centimeters, which side would fit nicely? Well, 20 doesn't go into 50, so that's not nice. 15 doesn't go into 50, but 10 does. So I'm going to match up 50 with 10. Looking at 60, or let's go for 80 first. So here, looking at 80, I'm looking at the two remaining numbers. Which number goes nicely into 80? 15 or 20? Well, 15 doesn't go into 80, but 20 does. And then finally, with the last one, I'm just checking, does 15 go into 60? Yes, it does. So I'm going to compare of how many sort of these on the dimensions on box B fit into the corresponding dimension on box A. So looking at this, I'm looking at how many 80s go into 20. Well, that's going to be 4. I'm then counting how many 15s go into 60. Well, that's going to be 4 as well. And then what I'm then going to do is see how many 50s go into 10, and that works out to be 5. So the dimensions of this particular question, or how many boxes I'm going to be able to fit nicely without melting or squishing box B in, is going to be 4 times 4 times 5, which is going to be 4 times 4, which is 16, times 5, which is going to be 80 boxes rather. So here we've got an answer of 80 boxes will fit. And there is my final answer. Now, if you were to do the area, the volume of A, then that would be 50 times 60 times 80, which equals 50 times 60 times 80 gives me 240,000. And if I then do the volume of B, which is 10 times 15 times 20, which gives me an answer of 3,000. And then if I divide the two numbers together, so 240,000 divided by 3,000, it would give me the correct answer of 80. However, as I imagined that even though, well, basically what this basically states is that there'll be no empty gaps in this particular box. However, if box A was marginally bigger, you don't want to be squishing in sort of volumes, in which if you use this second method, which I'm just highlighting here, you might end up with, let's say, a decimal answer, which it doesn't quite work. Whereas if I opted for this first method that I chose, then this method here, then I would be able to see how many of those smaller boxes fit flush into that bigger box. And that's definitely the method that I would choose. Now, if let's say I mix certain numbers up, so for example, let me just get rid of, let's say, all of this. let's just say, for example, I mixed up the numbers. So rather than going from counting, let's just say I'm going to pick up 3 random numbers. So let's go for those two. Let's go for those two. And let's go for those two. Now, ideally, this is not what you want to do. You want to kind of make sure you're thinking about the question first and seeing which numbers fit nicely. But looking at this particular question, if I see how many 50s, how many 50s going to fit into 15, and then rounding down the answer, that's going to be 3, rounded. Then if I go for how many 80s divide into 10, that's going to be 8. And then if I then do how many 60s go into 20, well, that's going to be 3. And again, if I was to do 3 times 3 times 8, then I'd get the answer of 72, which, although may gives me the answer, it's smaller than the correct answer of 80. So what you want to try and do is make sure you match up which numbers fit nicely with the other, because like I said, doing it the wrong way may give you a smaller answer. So that would definitely not be a good choice of orientation of box B to fit into box A. Now we'll put some practice questions in the description below for you to practice working out the volume of cubes and cuboids, and so you can practice everything you've learned in this video. And I'll include the answers in there as well for you to check your work, and I'll also add some notes should you wish to copy them down as well.